today's video, we're going to investigate the inner workings of a hydraulic pump that would have been fitted to the two-cylinder engine of a John Deere Dubuque 420, 430, 440 tractor, maybe a 330, from the 1957 through 1960 model years. This is a live hydraulic pump, meaning that it's constantly putting out oil as the engine turns. There's a little cog on the back of the shaft here that meshes with a coupling on the camshaft, turns two gears inside this pump. They're putting the oil out at about a 8 gallon per minute rate. What we're going to do is tear everything apart, dissect this thing, and see what the insides look like, rebuild, refurbish, replace as needed. If you'd rather just see the quick and easy version, we'll put it in our little box here. Throw in some tools, some new bearings, some sealing rings, need the Allen heads, a couple more gizmos for pulling O-rings and such, a little brush to clean everything up a little bit. Can't forget the elbow grease, double strength this time. That was pathetic. And then we will fold our little box up, give it a tap with the magic wand, and then with everything settled in there, give everything a really good shake. Gotta mix it up real good. And with that, with everything shook up really good, we are going to investigate the result. The Viola. Look at that. Beautiful. Clean, refreshed, rebuilt, and ready to go. Of course, in reality, it takes a little more than that, so keep watching, and you'll see how we actually took apart everything and what the insides look like. Here we have our hydraulic pump we pulled from the front of our 1960 John Deere 430 tractor, mounted on the front of that little two-cylinder engine. This same style of pump would have been used on the 440 tractors, 420 tractors, maybe the late 40 tractors. It's a fairly simple design. Two gears driven by the front of the camshaft. It turns this little shaft here. There's a gear against a gear. Low pressure comes in, high pressure comes out. There are just a couple seals, O-rings basically in between these plates, some bearings in there. The buff primer color on the front and the back makes me think someone has replaced some things in the past, being that it's not the John Deere green that you'd expect. We'll still dig in though and see what lies within and just give it a good overhaul. Probably going to take it over to the vise to loosen up these Allen head screws. There's one underneath there, underneath all the dirt. We'll take a field trip over there and get those out, see what the insides look like. We've loosened all our bolts. Just use the you can see that group of them are basically all the same size. This one, of course, is going to be a little longer, being in this bigger part. There's two alignment pins on each end that shouldn't hold anything together, and it shouldn't take but maybe a tap of the hammer. There's a little threaded spot. I think someone could put a screw in there, I guess, to aid in separating these two. Let's see if I can find that little scraper here. Don't want to damage our metal surfaces. They lie pretty flush to one another. We're off the other side. We can just, here we go. There we are. So there's our front face. Still a little bit of swirliness in there, but I can't pick up on too much of a gouged surface where the gear turns. Although that's kind of a unpleasant thing to find in your hydraulics. And we've got our two gears. And the gears, as I say, they kind of ride on these two shafts that are in here. You can see a little clip on each of these shafts that probably hold these gears in place. Keep a better grasp of that one. Just a little horseshoe clip. With that, our gear should come out of there. Let gravity do the work. One. There's a little keyway on the shaft here that holds that guy in there. I do not know if there is a difference between, let's say, just right and left on these. I'll go look in the parts book. We'll keep them kind of in their respective places here in the meantime. He likes it in there. Really, this whole shaft should come out of there. There we go. Yeah, because that's just the bearing holding him in there. And then once we, some more of that chunky stuff. Once we have our keyway here moved, pull him out. This shaft should push out forward, like so. There's a little O-ring up in here that we probably can't see at the moment between the shaft and the pump assembly. And then there's this piece here is just a kind of a spacer piece of metal, also held in place with these two dowel pins more or less on each side. So we'll see if we can gain some separation. There we are. Here we have the main pieces of our hydraulic pump apart. The front cover, centerpiece, rear cover, or it could be the opposite, either way. Gears, shafts. These plates have a little more wear to them. I really like. You may do, especially on this pressure side, there's kind of a bit of a groove in there. I'm thinking I'm going to go over to my parts section and, just like with all the other things on this tractor, dig out a spare hydraulic pump that I've got. See if I can find one that's got better surfaces on the inside, and we'll evaluate the gears and everything, but I think a lot of that's just wear from debris and such has gotten into our hydraulic system. So we'll give that a look. The bearings are not too hard to get out. There's a way of doing that I'll show you once we get to that point where we're going to pull them out and put new ones in. Big O-rings on each side of this center spacer. They'll come out from that little groove that they're living in there. And then the O-ring that we'll need to replace is down inside here. You probably can't even really see him all that well, but he's down in there. We'll pull him out and we'll get a new one to put in there when we put our new shaft back together. So we'll pull all that apart, we'll clean all this up and lay everything out and put it all back together. As you can see, there are once again multiples of a component on our table. I have a couple different hydraulic pumps here. The first one we took off our tractor. I was optimistic it might be in good shape just by the new old stock paint on the front, but it really has a lot of these scoring marks in here, and if you rub it over with your fingernail or even just a fine tip screwdriver, you can really pick up on the wear that's in there. So that way on kind of both sides. I did go ahead and take apart a second pump, and while it is much better, there still is, as you can probably see, a little bit here on the top. So I thought, we may end up using this one, but I thought while I was at it, let's take this one apart, see what the inside looks like. I don't know how well I documented taking things apart on the other. It's just a matter, I loosened these hex head bolts out. It was interesting on these other pumps, the bolts are this size, which I think is 7/32, but on this pump they're actually a little bit bigger as far as the head size. Can't remember what size that is, maybe a 1/4 inch, but different. They still seem to line everything up. The threads are still the same, so it's a curiosity. Anyway, we'll take all these out. It's just a matter of kind of tapping our front cover off. These two dowel pins sort of line everything up and act as a kind of an anchor point to secure the three pieces together. And there we have it. Well, as one can plainly see, that one's not much better. Even worse than the other two. Ooh. So we may end up fixing the best of what we have and call it good. This pump is going to be the one I think we put back together. There's a little bit of scoring in there, but I don't think it's going to be enough. It's going to cause us a problem. This thing's still going to pump plenty of oil to run the hydraulics the way we want to. This was our original. I'm not sure how you can see on the camera as far as just the little lines, the gouges that are in there on that plate. You could probably have these surfaced. If you put the spacer in the middle, that's going to be what determines the thickness of the gears. So you could probably have those machined down flat, get some of the wear out of there. But I think for our purposes, this pump is going to do just fine. Before I can go to maybe do a final cleaning, I want to take these bearings out that are in here. And there may be a fancy little tiny bearing puller you could go in there and pull those out with, but I do not have one. Instead, I'm going to rely on science and the fact that two objects cannot occupy the same physical space at the same time. And what I mean by that is I'm going to put an object, in this case grease, down here in this little pocket that the bearing sort of sits in. We're going to try and fill him up with this lovely substance. And it's a little messy, but I think you'll get the idea. Once we kind of fill that little pocket up, with that in place, I'm going to take one of the little shafts from this pump, take the clip out. I think this one's got the keyway in it, so it might be smarter to use the other one, but let's see if we can tap him out. There we are. And the more I look at that, I think I better use this other one here, because this has got a little smaller, well, maybe the diameter is the same. Yeah, we might be able to work with that. We'll take our keyway out here, like so. So now what we're going to do is take our shaft, stick it in there, and like I said, I don't know how much of a mess this is going to make, but if I tap this down, in theory, the grease should push down and then get to the outside edge of that bearing down there on the inside and push it out for us. There we are. Look at that. Science. So we get our bearing out like magic. And we'll repeat the process in a couple of these other cavities. 3 of these bearings are fitted in there the same way. So we'll do the same thing 2 more times and get our bearings out. Whole lot easier than trying to ream them out with a little grinder or anything like that. So those 3 are out. Now we have the 4th bearing. I guess I should, goes without saying, I've got new bearings to put in here, which is why we're taking the old ones out. This 4th bearing sits up here, so we've got the opening where this little shaft passes through. So of course you can't use that to tap it out. There's a little O-ring in here though. That, if I can find my baby screwdriver, there we are. You might be able to wedge him in there and get our little O-ring out. And then from here, we should have a surface that we can use to tap against to push him out that way. So I'll get a tap and we'll try this here. I might need a little more stability. I'm doing this kind of for the camera, but let's see. Let's just do a makeshift propping up here and see if we can. And we're free. So we have our bearings removed. Once again, these bearings are available from John Deere. Interestingly, this one I think is like $2 or $3, or these ones from John Deere are like $20. Of course, the ones you need more of cost more. It's a Torrington, I think it's a B-138, which as fate would have it is also a bearing used in a Harley-Davidson camshaft, if you're into some trivia. You can find these on eBay for about 10 bucks, I think, or maybe elsewhere if you've got other sources. So I'm going to go ahead and clean some of this stuff up and get it ready to go back together here, hopefully. We have our hydraulic pump components all cleaned up and ready to go for reassembly. While cleaning, I came across something interesting on our center plate. I don't know if the camera's going to be able to pick up on it, but there's actually a crack in that guy right there. And it goes around the whole piece. I don't believe that I did that taking it apart. I mean, anything's possible, sure. I could probably have done it, but I wasn't abusive or anything in getting that apart, so something to catch, and we'll just use our other from our original pump. Should have no issue carrying over. All the clearances and everything measured out just fine. But we need to go ahead and put new bearings in the back and front plates of our pump. There are 3 of the JD 8803s, which is also whether that's Koyo or Torrington, it's a B-138 bearing. Then there's 1 of the JD 8804. I didn't look to see what a part number was on this one. It was, like I said, this was $2 and some odd cents from John Deere, so no sense in shopping around with part numbers that cross over. We're going to press these back into our pump. We're going to go over the press and do that. Important things when pushing these bearings in. You always want to push on the side that has the writing on it, not the back side. The front side's where you push. And there is a clearance spec in the manual. It wants 60 thousandths from our flat surface to where the top of the bearing is, and usually that's somewhere right around where this taper stops. We can measure that a couple different ways. We can even cheat a little bit, and I'll probably end up using a socket as my press tool. I could even take this and put it on here and put a mark on the socket as far as how far it should go, but we'll get it pretty close to where we want it there. And so with that, we're going to go over to the press and start pushing some bearings in place. We're going to use the press to push our new needle bearings into our hydraulic pump housing. It's important to remember to push against the lettered side of the bearing. when we're pressing it in place. This plate is a little off center, so I'm going to use a little washer underneath there to stabilize it when we're pushing. And lastly, the manual calls for a 60 to 65 thousandths difference between where the top of the bearing will be and the top of the plate. So I've got my feeler gauges set to that so we can kind of check that as we go. And with that, let's see if we can push something in place here. Perfect. Take that. Okay. With that bearing in place, we can move over to the other side, which the other two bearings on the other plate are going to follow the same principle of this one, with the same clearance with the top of the plate. On this side, before we go and push our bearing in there are a couple pieces that go in there first. One is this little, it's a leather washer, and I was not able to find these through John Deere. This is the original one that came out of there. I think it's just a spacer, if nothing else, to kind of keep the other O-ring from riding against the metal surface of the pump. It measures about 0.05, I'm gonna say, thousandths. 0.05, yeah, 50 thousandths as far as the thickness. We're going to drop him in there like so, and then we're going to put our new O-ring in there, a U11647. It's going to be our seal, so the hydraulic oil does not mix with the engine oil. Down he goes. Seal and washer in place. Then we can push our new bearing in. This bearing's a little wider in terms of fit than the others, so I'm going to swap sockets. Very technical pressing tool. On this one, the manual calls for, I think, between 10 and 15 thousandths as far as the clearance between the two plates, so we're going to be a little less aggressive pushing him in. Kind of get him set there. Double check we're pushing against the lettering, and this one, the old one, I believe was a Torrington, maybe a B148 if you're looking for a replacement. Like I said, from John Deere, this one wasn't all that pricey, so. Nobody's home. I think we'll be happy with that. So yeah, we've got our two bearings in this back plate, and then we'll do the same thing with the two bearings in the front plate. Start joining our components back together here at the bench. Before I get too far in, I wanted to throw over here at the manual and show you that second bearing, the bigger diameter one that the shaft goes through, instead of 10 to 15 thousandths, it's actually 15 to 20 thousandths clearance between the surface of the pump and the bearing. So I was off a little on that, but I had the 60 to 65 thousandths right on the other three. That washer that goes in there, the reason I reused my original washer is I was not able to find that as a part available from John Deere or elsewhere, and that one was in decent enough condition, so that's why we went with it. And with that, we can start by putting our little pump shaft back into its bore here. Before I do that, I'm going to pack this little pocket with a high pressure, high temp grease. And we can take our little pump drive shaft and be careful not to bind the O-ring when we go in there, and just sort of gently give them a little turn as we're advancing. The manual makes mention of a little sleeve that you can use to help install this, and of course, as is typical, I don't have that little sleeve, so we're just going to be gentle with our, there we go, with our advance, getting them in there. Hope that we didn't shear that O-ring, but by the way it feels, I don't feel that it was compromised. Feels fairly snug, which is good. So with that, we are going to put a little woodruff key back in here. My original was kind of worn where the gear slides on there. There's a little bit of an edge. So I went to my little assortment and found a new replacement. Put him in place. And slide our gear back in there. Our gears, there's a wider opening and a narrower one. It's the wider one that's going to fit over that woodruff key. And these two gears, side to side, they are interchangeable, so you could use, theoretically, either gear on either side. There we are. Yeah, we ought to be able to, there we go, advance him enough that we can get our little clip in place now. That grease is some sticky stuff. Yeah. Okay. Take one of our little horseshoe clips, and there should be enough clearance to push him in place, and try not to get your glove in there. I think we're okay. We don't need that in our hydraulic system, that's for sure. And we can get our second gear, slide him on the little idler shaft, and we'll put our two clips on either end of him. Like so. And like so. So that gear does not have a woodruff key, it actually spins on the shaft itself. Now I'm going to put a little bit of that grease down here in this pocket as well with our bearing. Mesh these together and slide him in place. Then comes our center ring. This is the important part when it comes to the gears. You could probably machine these surfaces if you felt bad enough about the wear. This thickness isn't going to change, and this is the thickness that should relate to the gears. So that part will remain static, and we're going to slide him on there. But before we do, we need to install our little sealing rings. These are a T16572. A lot of times what I will do is add a little bit of grease to this part of the process too, to keep these rings stuck in place while I'm trying to line everything up. Just hooked a landline up here in the shop. I'm not really inclined to answer it because my fingers are covered in grease. Probably somebody wanting me to buy something anyway. So with that, should hold our ring in place, and we can slide it over our dowels into its proper anatomical location in our pump. I believe our O-ring seal is still in a good way. You can check and feel. There's a little bit of clearance between the edge of this plate and the edge of the gear. We're just a little bit higher on the plate, which is of course what we want, because we don't want to bind the gears when we're turning around. We're still going to have to squeeze together a little bit when we put our retaining screws in that hold all this together, but having that little bit of clearance is good. Of course, when I set it this way, that little drive shaft is going to push this gear up a little bit. That'll all correct itself once we get everything together with the bolts. Maybe not as critical to grease this sealing ring, but might as well be thorough in our work. Take our plate, probably put a little bit of our moly grease on our bearings in here, just to make sure they're good. Good and lubed up when we go to spin this thing around. And for good measure, we can a little bit of our hydraulic oil and a little coating. Ooh, I might be running a little low. Time for a refill. Like a sandwich. Hydraulic sandwich. Back together. And then with that, we will install some of our retaining screws. There are 4 here on the outside. Longer of the 4. I'm sorry, there's 4 of the similar size plus 1 longer. The 1 longer one goes in, I believe it's this hole here. Yeah. And then it's just a matter of making sure you guess the correct spots for the rest of them. I think it's going to be these openings that have this little recess, because these openings will be where the pump mounts to the engine. So where we see that little lip, that's where our screws are going to go in. You must really want to sell me something. Now buy. Okay. We'll get our little Allen head wrench. Tighten this up to a snug fit here, at least on the workbench. And then what we're going to do is we're going to take this over to the vise, hold it in place. I believe the manual calls for a 28 foot-pound tightening of these screws, so I can do that kind of over there at the bench without you having to bear witness to it. But there you have a more or less rebuilt John Deere 420, 430 two-cylinder tractor hydraulic pump. We'll put that in a little bin with all the other parts that we reworked and move on to another project that might either be the clutch, the front axle. I've got a couple of things waiting in the works that we can document, but for the time being, that is our hydraulic pump. Hope that was a help to you if you're rebuilding one of your own, or maybe you just learned a little bit of something. Appreciate you watching.